Greetings everyone. So this will be the video discussion for the continuation of our topic under nucleosynthesis. So before I continue with the remaining 15 slides, I will be having a review first. So as we remember, after the Big Bang event, there was Big Bang nucleosynthesis, the formation of light elements, correct? So during that time or after that time, the universe started or is continuing to expand. If you remember, I mentioned before that the universe is like or is represented by an inverse pyramid in which you can see the expansion is continuing until now. This continuation and at the same time the formation of elements and matter at the same time will or is brought about by the decrease in your temperature, therefore allowing some matter to exist. So after your Big Bang nucleosynthesis, we are now in the stage in which we call the stellar or the star nucleosynthesis, meaning it occurs in your stars. So don't forget, until now, hydrogen is the most abundant element, followed by helium. Hydrogen, 75%, and 25% for your helium. Okay, let's continue. So after the Big Bang nucleosynthesis, we are now in your stellar or known as the star nucleosynthesis. This one talks about how heavy elements, for example, your iron, nickel, etc., form inside the star. So remember, when we talk about heavy elements, this one occurs in your stars. Okay? Now, as I mentioned before, as the universe continued to expand, together with the less or decrease in temperature, after the Big Bang, matter was initially uniformly distributed, meaning all around that small space, the matter is uniformly distributed all around the place. But as the expansion continued, these matter started to create lumps or they lump together. Some of which clump together, nagsama-sama sila, to become now the what we call the proto-galaxies or the start of galaxies. If you imagine this is like a smoke or a cloud of matter. So they started to clump together and that started the creation of proto-galaxies. Now, if we go further, so this one is in a large scale, okay? Hindi siya maliit lang, but in a large scale. So if you can see in the GIF image or in the GIF here, this one represents the clumping of matter in randomly, not uniform. From being uniform distribution, now we have here ununiform or in randomness. Okay? So if you go inside and look inside these proto-galaxies, there are these forces now, the gravitational forces that started to collapse this matter for them to become one. So, ibig sabihin, from these random clouds of matter, nagkaroon ng force, namely the gravitational force, attracting all matter to form different celestial bodies. In this case, these are your stars, your galaxies, and etc. Okay? Now, the two key processes of this stellar nucleosynthesis are nuclear fusion and neutron capture. So, we'll be focusing on the two. So take note, the very first or the forces that brought about the formation of this matter is because of your gravitational force. Matter going together, forming lumps, which we have now the sun, okay, or the stars. Now after that one, okay, nuclear fusion started to emerge. Now, what causes the formation or the existence of nuclear fusion? Now, let us first divide nuclear and fusion, okay? When you say nuclear, that talks about the nucleus, okay? Or the reaction or the change in the nucleus of an atom, okay? So, these atoms are the ones we produce during the Big Bang nucleosynthesis. So, dumami ng dumami sila because of random event, until they formed now different matter and they started to react because of the formation of the stars inside the lumps, okay, of those proto-galaxies. And when you say fusion, it is just the combination. You add something into another one. So you fuse something. So this one is somehow fusing something towards your nucleus or fusing nucleus into another. So you are putting together two atoms of this, two different atoms, you put them together and they started to fuse. Now, since I talk about gravity acting on this matter, they are going together, they form this now, the what we call stars. Now, because of gravity, these stars started to form and they started to collapse. When you say collapse, naging isa, mas naging compact into one circular star. Okay? Collapse. So parang bilog siya. Then the internal temperature, because of the increase in gravity, increase also. So because sobrang powerful ng ating gravity, pulling all matter around that certain star, na nag-form na star, the temperature is also increasing. So you might analyze it as the deeper you go inside the star, the higher temperature because the greater the gravity is. Therefore, because of this existing temperature increase and gravitational forces increasing, nuclear fusion now becomes possible. So you are trying to embrace the two concepts together for us to have nuclear fusion. So this is one of the processes so that we can achieve stellar nucleosynthesis. If you remember, in our Big Bang nucleosynthesis, we only need two, correct? Decrease in temperature and the randomness of them bumping together to form protons and your isotopes and the very first elements. In this case, stellar, it needs a high temperature, increase in temperature, and of course, because of the gravity. Now, let's say you have now your star. The star now is formed. Inside the star, series of fusion or combination of nucleus are happening in the core, followed by shrinking and temperature rise. Again, what causes the shrinking? Because of the gravity pulling all the matter in the middle, forming it or causing it to collapse. The collapse now is the shrinking of matter inside. So sobrang init, nuclear fusion now is possible. Now, because of this, it triggered elements from the Big Bang nucleosynthesis to form now your oxygen, your carbon, until sa pinaka-heavy elements, which is your iron. Just remember, when we talk nuclear fusion, it only occurs where? Inside the star or inside the star under your stellar nucleosynthesis. And it needs or it requires a shrinking because of gravity and temperature rise because of gravity also. So this will give rise to your heavy elements. Okay? Because pag sobrang init, they are forced to react with each other, bump with each other, and sometimes they create new type of element. So para siyang baliktad ng ating Big Bang. Big Bang requires a bit lower temperature for them to stick together. But this time, because it's too hot, nuclear fusion is possible. So what happens inside the star now? Okay? I hope you're following. Now, because of this, your stars now started to evolve. Now, it depends upon the matter that they're able to accumulate. At the same time, how powerful, how big your star is now. Because as they started to become a true star, they are evolving. So that they look like or they have someone like different layers, an onion skin-like shells of successively heavier elements. That is why, if you look at this diagram, it represents the layers. So as you go further or deeper in your star, what you notice here is that these elements heavier or it becomes heavier. Mas bumibigat habang or we go deeper or pupunta sa ilalim ng sun. Again, bakit mas nagiging heavy ang element? Because the heavier or the deeper we go in the star, the higher temperature and the more gravitational force is present there to give rise to your nuclear fusion. Sobrang kainit, they started to create now your heavy elements through, again, nuclear fusion. That's why different thermonuclear reactions, tinawag siyang thermonuclear kasi it requires high amount of energy through heat and the reaction in the nucleus of your atom. So in this case, from hydrogen, helium, and until maging nickel and iron. It depends, okay, on the star. And aside from that, take note ha, only if 10 and up ang kanyang solar mass. As I mentioned before, when I talk about solar mass, this is the comparison of our sun and with another star. Therefore, if it's 10 plus or 10 ang kanyang solar mass and higher, it is 10 times bigger or more than our sun. That will be the first requirement for how we are able to create heavy elements like nickel and iron. Okay? Silicon and sulfur. So as you notice, mas malalim, mas mabigat yung ating element kasi mas mainit at mas malakas ang gravity. Okay? Now aside from nuclear fusion, in a star, there's also what we call neutron capture. So from the term neutron, we are trying to capture neutron and etc. Take note, I mentioned also that an element that contains a lot of protons can only carry a certain amount of proton because it's already a positive charge or it contains a lot of positive charge subatomic particle proton. Therefore, hindi na kaya ng ating proton kahit sobrang init pa or ng ating element, even though it's too hot, for it to carry or accept another proton. Because as I mentioned, same charge, they try to repel each other. Correct? Now, if it's opposite charge, they try to attract or they try to merge or combine. If it's, for example, positive or without charge, it's possible for them to attract. Later, I will explain how is it possible for a neutron to be captured by your atom instead of capturing a proton. Now, focus on this one. Okay? Protons carry a positive charge. We already know that. It's tough to stuff more protons into heavy atoms. That's why mahirap magkaroon ng heavy element if we accept more protons because prior to that, that element or that atom is already containing a lot of protons. Therefore, it's already positive. Therefore, it can only accept your neutron. Again, bakit hindi mag-accept ng proton? It is too powerful ang kanyang repulsive positive charge. So, hindi siya pwede mag-accept ng powerful na repulsion. Itatapon niya lang palayo si proton. Fortunately, there are neutrons. Dito na papasok yung character neutron. Very important for us to create heavy elements inside the stars. They are electrically neutral, neither positive, neither negative, and so can slip into a nucleus easily. That is why, okay, let me see if nandito sa aking slide. No, not this one. Okay, now under neutron capture, for an element or an atom to capture a neutron has the capacity to become. Okay, so take note of this one. All neutron, because an element cannot accept protons na, kaya daghan na kayo, a neutron now has the capacity or a secret weapon to transform into protons. Diba, kailangan natin ng proton para yung isang element maging mabigat. Paano makabuo ng iron? Pag yung proton ng element before iron, hindi ma-accept para maging iron. So, the magic is with neutrons. The neutrons now will be captured here. Let's say this one. Na-capture niya si neutron. Okay, si proton lumabas or hindi inaccept, lumayo. Okay? The neutron here, once it's inside the nucleus ng ating element, this has the capacity to become a proton. So, at first, na-accept siya. Pag na-accept na siya, pwede na siyang mag-transform into proton at hindi na siya pwedeng ilabas. So, this reaction now will release another photon. That is why, sa stars, neutron capture is also one of the reasons why your star is emitting light. Powerful light. Depende sa light. Blue, yellow, or depende sa color. That will tell you how big, how powerful, how hot is the star. Or how hot is a star. Okay? So, pwedeng yellow like our sun. our sun or our solar is normally yellow. So hindi ganoon kainit compared sa blue or almost whitish na flame or light ng isang star. So remember ha, you can only capture a neutron inside a nucleus of an atom to make it heavier. At the same time, it can transform to become a proton. So mag-iba ang kanyang charge, maging proton, maging positive. Therefore, itong element na to maging mabigat. Okay? Kasi may neutron na nagdagdag. The reaction now will release a photon. That's why your star can emit light. Okay? So there are two types of neutron capture that might happen inside the star. First type is what we call the S process, and the second type is the R process. So let us now dissect each of them. First, S process. As I mentioned in the review, S process means slow. Okay? So neutrons enter the nucleus much slowly, and they can create, for them to create protons. Okay? Pagpasok nila sa isang element, it will take time for them to become a proton para ito maging mabigat. So it takes time. Normally, it takes place over thousands of years. That's why it's called slow. So I don't like to complicate these things. I just like you to remember that the S process is the one responsible for about half of the element heavier than iron. Because for you to be heavier than iron, it will take you a lot of neutron and a lot of time for those neutrons captured in the atom to become a proton. Do you get me? That's why yung sun natin until now, nag-undergo siya ng S process. That's why our sun, pag maraming element, for example, present there, and marami siyang pwedeng ma-burn, therefore the sun can last for millions or billions of years, burning all these elements inside it. Kasi S process yung ginagamit niya. Clear? So, remember in the exam, heavier elements or heavy elements than iron is created by R or S process. Okay? It takes thousands of years. Now, its counterpart or ang kanyang, let's say, kabaliktaran is the R process or the rapid process, mabilisan. So, including its heaviest members relies on rapid neutron capture. So, the rest of the periodic table and the other heaviest members, okay, relies on rapid neutron capture. So, in this process, your atom is bombarded by a number or a tsunami of neutrons. Marami masyado. Therefore, the more neutrons it can capture, the more protons will be produced kasi maraming neutron na ma-transform to become a proton. Therefore, it will become a heavy element. So, just remember, when we say S process, it takes 1,000 years or 1,000 years for it to form because maybe one at a time lang yung pumapasok na neutron. And our process, we have now the numerous neutrons entering your atom at the same time. Sometimes you can create a new atom or element just by or only within 1 second or few seconds lang or minutes. Kasi sobrang dami ng neutron at mas mabilis yung pag-transform niya to become a proton. So yun ang differences. S is slow ang kanyang process ng neutron transformation or neutron capture. Our process, mabilis ang pag-capture niya and it will only take few seconds or minutes. Okay? Now, sir, bakit yung isa slow? Bakit yung isa fast? Now, take note ha, pag ang slow process kasi, it normally happens pag yung star mo is aging na sa loob niya. Meaning, matanda na yung star. Okay? So, parang marami na siyang na-burn at the same time. And normally, ang kanyang internal is mga elements higher than your iron. The R process, rapid process, this normally happens in stars na almost young pa lang or almost bago pa lang siya. Therefore, ang kanyang elements na meron is medyo magaan pa. Therefore, yung element na yun can accept more neutrons. Okay? That's why sa S process, let's say yung mga element na nabuo niya is medyo heavy na and hindi na masyado nag-accept even neutron. Mabagal na lang yung pag-accept niya. Okay? Kasi mabigat na siya prior. So parang pwede mo sabihin, R process first, followed by S process. Okay? Now, let's move forward. I hope that's clear for the stellar nucleosynthesis. So next topic is synthesizing elements in the laboratory. How can your scientist or different chemists create these elements inside the laboratory, or why do they need to create these elements? Maliban sa binigay ni Dmitry Mendeleev prior. Okay? So once the known elements were tabulated in the form of, as we all know now, periodic table created by Dmitry Ivanovich Mendeleev. He is a Russian chemist and a teacher. So he's the one who created and devised the what we know now, the periodic tables. Here in the picture, that's him, his actual picture. Sa baba, yan yung pinakaunang periodic table created by Dmitry Mendeleev. So he based this one by atomic number. Okay? So H or hydrogen is number 1, as we all know, kasi siya pinakauna and pinakamagaan sa ating elements. So as you can see, as you go further here, mas bumibigat ang ating element. Do you get the flow? Mas bumibigat. And what else can you notice? There are empty spaces. Therefore, during his time, these elements are not yet created or discovered. So wala pang element na meron ganitong atomic number or atomic mass number. So therefore, ang nangyari sa first periodic table na ginawa ni Dmitry, may mga empty spaces to give space for those elements that are not yet discovered. Okay? So as time goes by, as our technology is improved, we have more studies conducted, and different countries are able to conduct their own private studies in their laboratories, and they try to create elements because these elements that they can create can be a source of power. Like nuclear power plants, they use highly reactive na elements like uranium. Okay? Now, after them creating this one, elements now that we have is present in your periodic table. Now, this is, as you can see here, your present periodic table. Again, andyan naman si hydrogen followed by helium. Okay? So as we go deeper or go lower in your table, mas bumibigat yung ating element. So take note of this one. Yung mga color red, I guess, or color, I don't know, in your screen, pink, I guess, these are the purely synthetic. It means that, remember, when we talk about synthetic, these elements are not or does not normally exist in our nature or doesn't exist naturally anywhere. So these are created inside the lab. So ang ginawa nila, they tried to bombard it. So later I will explain how they are gonna do or gonna perform or what they are doing for them to create the element. So these are the elements. So as you can remember, mostly elements after uranium are all synthetically created inside the lab. So remember, these elements that are synthetically created are called transuranium or transuranic elements. Okay? Now, sir, why is it that they cannot exist naturally in the world or sa nature? Bakit hindi siya makita kaagad? Like, hindi siya pwedeng imina or imine. Like, for example, gold and iron. Now, the reason is this one. Very simple. These elements, the heavier they get, the harder for them to exist in a natural world or setting because the heavier you are, the more reactive you become. The more reactive you become, meron siyang decay. Ibig sabihin na de-decompose kaagad yung element because nagre-react siya sa surrounding elements. That's why hindi mo pwedeng ilagay lang kahit saan. For example, sa uranium, ilagay mo siya sa bahay, i-display mo sa table, naka uranium sa akong kwarto After many days or few days, you started to create or to develop cancer. Kasi that uranium emits beta decay or gamma rays outside because nagbe-beta decay siya. Meaning, it releases a ray or rays outside para, kasi reactive man siya. Everything that surrounds your uranium will react with the uranium. So therefore, it releases rays outside in a form of gamma rays, depende or because of beta decay. So hindi siya nag-exist normally. And if they existed before, possible na yung pag-exist nila sa early Earth, it gave them enough time for them to decay. That's why pag abot sa ating present time, there are no more left of them. Kasi may theory na dinasabi, these elements na nag-exist sila possible noon. Pero since ilang billion years na ang Earth natin, it might be possible that they are already decayed or wala na sila nag-exist. That's why ginawa sila ulit in the laboratory by neutron bombardment and cold fusion. Let us try to separate the two. What do you mean by neutron bombardment and cold fusion? Therefore, remember these are the two processes on how we can create your synthetic or artificial neutron. Artificial element. First, neutron bombardment. So from the term neutron, we add neutron, no charge, to become proton later on. Bombard meaning i-force mo siya, bahain mo siya ng ating neutron. Sir, is it the same with your stellar nucleosynthesis? Not really, because it only happens sa star, or it can only happen sa star in extreme temperature and gravitational force. Here, it can be created inside the lab. Okay, so we try to force a neutron, one neutron or a number of neutron randomly in an atom. For example, here we have an element uranium. Okay, 235 ang kanyang atomic number. When you bombard it with neutron, take note di ba neutron lang pwedeng ma-accept? Why? Because that will tell the element to become heavier or not, and because of the proton na meron na kay uranium dati pa, hindi na pwedeng mag-accept ng proton. Neutron na lang kasi si neutron pwedeng mag-transform to become a proton. Now, notice, naging 236. Now, dito lang, in few seconds or minutes, mag-exist ang ating uranium-236. Beyond that, it will undergo beta decay. Ibig sabihin, this will become reactive, very reactive, producing your different elements, like this one, and another 3 neutrons, and another element. Kasi, hindi na siya uranium. Because you're adding neutron now, dito lang na area here, dito lang siya naging uranium-236 or heavier. So it will undergo decay instantly. That's why all or most synthetic elements, as far as you can remember, they don't exist in long periods of time. Dili sila mag-exist dugay. Dali lang kaayo because they normally decay as fast as possible. That's why mabilis lang sila nag-exist. Okay? They emit beta particle outside. And that is very dangerous pag matamaan tayo. It can decompose or it can destroy our genetics or genetic sequence. Okay? That's why merong cancer. Yung iba, they have problems with their immune system and the rest. Okay? That's why when you talk about nuclear energy, nuclear power plants, it needs a high, it has high risk and it needs high maintenance kasi possible na magkaroon ng meltdown and mag-release or magtakas yung ating mga radiation outside. It can really kill or affect every living thing, the mold, mga insects, animals, and of course, humans. Okay? Aside from neutron bombardment, we have now the second one, the cold fusion. Now, I will not be focusing much in this one because cold fusion and some chemists or chemistry or some chemist people or mga chemists I supposed to be, they say that cold fusion is somehow a fallacy or hindi siya possible. Marami siyang flaws. Kasi it's impossible kasi ang cold fusion ang kanyang nature is you decrease the temperature until such time na ang kanilang molecule magdikit. But it's not normally possible because it's hard to produce a very low temperature in the laboratory in a setting for an element to really combine. Kasi take note, we have to consider first the space, the type of element, and the number of protons in neutron in the element. So temperature is the main the main control, which is decreasing the temperature cold enough for them to become one element and to overcome repulsion. So parang i-force mo siya because sobrang lamig kasi normally what will happen with your atomic particles, they will start to combine or magdikit-dikit sila. Like water turning to ice. Okay? So that is the thing. Pero don't focus much kasi medyo hindi possible normally ang cold fusion. Okay? So that's how we are trying to create your synthetic elements. Next, so the newly named artificial elements, so I will only be highlighting 3. Okay? Sa ating table, sa ating periodic table, marami pa masyado. So element 1113, element 114, element 115. Okay, element 113 pala. So before, ang tawag sa kanya, UUT, and naging nihonyum because it is made in the Japanese laboratory by Japanese people or by Japanese or people of Japan, mga scientists nila doon. So ito sila lahat na element, they only existed in microseconds or a few seconds lang kasi they are very reactive, mag-undergo kaagad ng beta decay. Okay? So element 114, before was known as UUD ata, UUD or UUN, and later on naging flerovium to give credit to the scientists or the laboratory where they created this one. So yung lab naka-name sa isang scientist or sa isang Russian chemist or physicist known as Georgy Flerov. Okay, so tinawag siyang flerovium. Second, si element 1115 known before as UUT or UUP. Okay, it was later on named as Moscovium, recognized the Moscow region. So most as you can notice, this one occurred during the USSR or during the time na naglalaban yung America and Russia. Sino yung mas magaling sa science? Like for example, rocket science, who is the first person to go in the outer space, in the moon. So ito yung rise ng ating scientific discoveries between two nations. Okay? So that's it. Continue. So that will end, or that ends our lesson for today. So don't forget, after the exam week, you need to have your journal log with what we discussed from the discussion, the normal Zoom class, plus this one, the video discussion. And if you have questions, you can ask me directly through chat. And lastly, we are able to do all of our objectives, or we're able to meet the objectives. Okay, so thank you everyone, and I hope that understand the lesson properly. So I know I tried my best to really dissect all the lessons based on your level, and I hope that you learned something new today. Okay, so God bless in your exam once again, and have a nice day and stay safe. Thank you so much.